We're all good?
Yeah, we're all good.
All right, so thank you everyone for coming out tonight. I know it's a little rainy outside. It's looking a little gloomy. It's hot. Summer, I guess it's a hot summer Florida day, or hot Florida summer's day. I learned how to talk one of these years. But thanks for coming out. It's really cool to see everybody in the community. I'm going to give a speech, which is, you know, get up here and talk. I see plenty of new faces that I haven't seen talk yet, right? I mean, I go through out, but the deal is if you want to learn about something, so does everybody else in the community. And I am going to call out Andrew, though, because I haven't seen you talk in a while.
He's doing it in 2 weeks.
So, all right, in 2 weeks, we'll get to see it, so we appreciate that. Other than that, thanks for coming out, and I'm going to turn it over to Caitlin, and she'll tell you all the good stuff, because I don't know any of the stuff. So.
No, you don't. You don't. If you guys were there for the JavaScript meetup, I was not here for. I made sure everybody was well aware that I did not give him a list of events that were happening.
That is true.
So for those who have never been here before, I'm the community manager for CloudSpace. I am also now going to be the first person you want to get a hold of if you want a job. So I am handling all recruiting, all hiring, the pre-stages of it. So you bug me and then I'll bug my internal staff. So for that being said, come to me before the recruiters. That would make me happy. Also, too, if you're in school, huh?
But everybody loves recruiters.
No, there's a reason why you come to my meetup, and there's really no recruiters here.
Yeah, all my LinkedIn skills.
You got your job from here. Partially, yes. But going here. Just saying. There's a lot.
Watch out with her. She fights.
There's a lot of companies who come out here who are, I'm completely open to other companies coming in and being like, hey, I'm kind of hiring. Awesome, let's do it, because obviously I've got a lot of students who come through here. I know the Iron Yard very well, so they support us very much so. Full Sail comes out here all the time, and so does UCF. So I've got a good pool of it. Not a big fan of recruiters, but I do love to come in and pluck some of you guys to keep you in Orlando. Things coming up. Is there anything code for Orlando coming up?
No, there's
The meetup's in.
meeting last night, but
Oh, sorry guys. There was a meetup last night. Had no idea about it.
I think the flag voting's coming up soon.
So changing is it the city or the county flag?
City. So has anybody seen the city's flag? Are you aware? Or well, you haven't seen it because it's the worst flag ever. So, Code for Orlando designed a new flag last month. And is that they've come up with a few designs now, and I think once it goes through like initial voting, we'll have like 2 or 3 flags, and then we're going to try to get constituents to vote on it, and then push it to the city to actually make something better. Along a bunch of other guys are into like resume padding. We have a ton of projects that you can just work on. They're all on GitHub, and we'd love some help. So everything from doing programming to talking to people to just throwing in your opinion. So commitment.
Yep.
When you say we,
Code for Orlando. There's probably about 40 or 50 of us. Once bi-yearly, and like we just had one, and those are fun to go to. Free food, free drinks.
Yep. If you guys ever want to know of anything, just bug me. But please do it by like email or Facebook message, because I will forget. I love paper trails. Otherwise, I will completely forget. Speaking of which, there was somebody who was supposed to speak. Okay. I need.
You
Yeah.
are forgetting one of the top 10 event being put on by Pizza Hut.
What?
Give you a hard time. If you guys missed his Android talk last week, he ripped apart the Pizza Hut app. And by ripped apart, I mean ripped apart.
which by the way, when I was coming out here, I saw they also fall vulnerable to a unprotected SSL login information attack.
If only they had millions of dollars to dump into something like that.
We do live stream these. I'm telling you guys, go into YouTube and find the Android talk, which was just last week, and look at it. He was the first You're going to die laughing throughout the entire thing. Never tick that one off because he will publicly embarrass you. Okay, so let's get the show on the road. In between speakers, I will make sure all of you guys have your tickets because we do give away a book, a couple swag bags as well. We're remarketing, so t-shirts are on hold right now. We normally do give away t-shirts, but they're on hold. But I have swag bags and then a book. We like to keep up. So with that being said, Matthew, this is a special guest who's come from, you're still out in Tampa, aren't you? So Tampa, he came all the way out from Tampa to speak, but he's also spoken at Downtown's Ruby before as well. That's how I know. So Matthew, you're more than welcome to come on up here and give yourself your intro. Cool. Just clip that on your shirt so the YouTubers can hear you.
Where's the best? Just
anywhere? And then
just wherever.
We haven't heard anything through the PA system. It's all
say what?
projection. That microphone isn't doing anything.
Oh, is it?
Everything for YouTube.
Oh, it does everything for YouTube. I'll try to speak loudly. How's that?
Thank you very much.
I have a loud voice, so sadly these guys are tired of hearing me.
Well, they're not going to get any relief from me. I've heard I'm way too loud. So, let's see here. Let's first of all, my slide presentation skills are absolutely horrible. So that's why I only made one slide, and the rest will be just code and demo types of things. So, so you'll get a slide. It's just some about me and about the talk. Let's see if I can even find it here. Yeah, there we go. I don't even know how to go full screen with it, but so here's my, like she said, my name is Matthew Thomas. There's my super fancy slide, right? I currently work with Malwarebytes. Malwarebytes is based out of San Jose, California. We protects computers against viruses and malware, different types of malware and hackers and things like that. We have an engineering office in the Tampa area, and a whole bunch of people. So feel free to check out our hiring page. We're not a recruiter in the traditional sense. We're a company, so I figured it might be okay. So feel free to check that out. We're also a company to work for, and by the video that you check out. This is an actual video that was put together by one of our employees. Every year we do an off-site retreat, kind of company summit type of thing in Vegas a couple of months ago, and so that's kind of this interesting video of. It's actually the guy that did a great job. There's my email. Questions or any questions about the company or jobs or anything like that, don't hesitate to me. And a couple of GitHub repos throughout this or this talk. Yeah, the name of the talk is giving. One other thing before, because I know this always comes up. Yes, the sideburns are real. No, I don't color my hair at all. Nature did this to me like, I don't know, like 15 years ago, and so I just kind of go with it. So that's right. So, but I get to ask that at least like once a week, so I figure I'll just go ahead and clear that out of the way now. With that out of the way, yeah, that's right. So I'll zoom up here so you guys can see. Hang on, let me bring up my notes over here. So, so the talk is about. We're actually kind of lucky today because both of the talks will I think complement each other really well. So hopefully this will go well. So the talk is about building Ruby native extensions in C and C++, and to talk a little bit about why you might want to do that. I found myself having to do this at my day job for a particular project, and I thought, well, this is an interesting problem that I have to solve. It might make for an interesting talk for 15 and so that's why I put this together. So as you know, interpreted language, but sometimes there are interesting reasons why you might be able to, why you might need to be able to language. In other words, to allow the language to do things that it doesn't do. And one way you can do that is by using C and C++. Now Ruby, as you the most popular Ruby interpreter out there is based in C and actually in C, and so writing native extensions for it is actually kind of a relatively natural thing to do. So before I dive into the actual extensions themselves and how to do it, and we'll get into the mechanics of it here and code of it here in just a moment, I ran into this problem where I had to. I had to build functionality into the application that that currently existed in some other C and C++ libraries that some other people in the company were using. In fact, those C and C++ libraries were actually written in Windows, Win32. It was a lot of code. We're talking several thousand lines of code. My options were rewrite all that in, let's say, a gem or something like that and bring that into our Ruby application. Or I could try to port that code from Windows, get the C and C++ code to run on Linux under the build it under the GCC G++ compiler, and then that into our Ruby stack via a gem. So I chose the latter. I decided, well, let me try the latter option and see what that is. Fortunately, it turned out to be not too bad. The hardest part was getting the Win32 C and C++ code to compile in a native Linux GCC G++ environment. So that was probably where I spent probably the bulk of the work. Is just figuring out the best way then to wrap and expose all that into our Ruby application, or one of our many Ruby applications, as a matter of fact. Kind of more general, I thought, well, that's not easily. I can't really do a demo with that. That's kind of hard to demo. Right? Where one might need to wrap or to be able to a native extension in C and C++ that would actually be kind of useful, right? So it dawned on me, well, you know, I looked a little bit at the Ruby math libraries that are available. And frankly, they're not that great. I don't know if you've ever explored them before. The Ruby mathematics libraries are yeah, so-so. And they're kind of interesting to me. By the way, I went to school like before most of you were born. And I have a degree in mathematics, so that was kind of interesting to me. So I decided to take a look at them, and wasn't really jazzed by them. So I thought, well, there are a set of C libraries that expose some very interesting mathematics functions in a library package called Boost. Now I don't know if you guys are familiar with the Boost libraries from the C++ world. Anybody here actually used them before? Oh, good. So a few people are familiar with them. So if you're not familiar with Boost, Boost is a set of standard C++ libraries that this project started. It's an open source project started ago by some really, really smart people. The libraries are very mature. They're very robust. They're extremely well tested. The documentation is pretty good. It's been a over the course of many, many years. And it's really quite popular now, especially since C and C++ is making kind of a big comeback, largely due to mobile devices, and as well as Internet of Things types of devices. So Boost is actually really popular, and it's really well-maintained code, and exposes some interesting functions that I thought, well, this might be interesting to show how you might bring the Boost libraries into your Ruby application. So that's a little word about Boost C++. That's the why of why we want to do this. That's why this is I thought this would be an interesting talk. Is that I wanted to show that, hey, there's some interesting math functions in the Boost C++ libraries that don't exist in Ruby, and how could we expose those capabilities in the stack? All right. So with that in mind, let's just dive right in. Come back. There. And I'll zoom up here so you guys can see. This mouse is a little wild, so you'll have to bear with me. All right, so to make this all happen, the first thing that I had to do was set up the environment. So the environment that I'm running in right now, this is an Ubuntu environment. Many of you probably recognize the default. How many of you guys actually use Ubuntu to develop in, or have you Mac to develop? I see. That's cool. That's cool. As you can see, I'm a Linux guy, but I needed a beefy laptop, so I used a Windows machine with running Ubuntu in the background under VMware. So the first thing I want to do is just talk a little bit and how I set up. So the first thing, so the Linux distributions by default, this particular Linux distribution, Ubuntu, does not come with Boost libraries installed. So the first step was to actually then go ahead and install them. So the steps for doing this, and I have full notes on this out in that I referenced earlier, and I'll be happy to post in the meetup room afterwards, so you can read all the notes that I'm kind of going off of here. So the first thing to do is actually to set up and install the Boost libraries in your environment. So I'll show you just quickly how that works. hopefully this will go well. Can everyone see the letters? Okay. Let's see here. So the first thing you have to do is actually download the Boost libraries, and I'm not going to go through the actual steps because this will all take way too much time, and it'll go like for an hour. Very, very quickly what I did. So you download the files, you unpack them, and then inside the Boost files, there's a way that you actually bootstrap the installation. So basically, what you do is you run something like this. You would run something like that, where the prefix points to the location that you install local, or basically space for the that you want to actually ultimately install into the operating system. So you would do that, and then you would actually run Boost tool to build the Boost libraries, and you would want to. And in this case, this is what I did. I actually built libraries using the particular command, and this is I linked had a little bit more detail and explains what's going on behind this. But what's actually happening here is this will actually kick off a compilation process that will probably last about 45 minutes. Right? What it's doing is it's building from source code the entire Boost library set. Right? It's actually pretty. There's a lot to it. So we won't do that now because we don't have the time for that. But just it'll happen, and then after about 40 minutes later, you'll have fully built, fresh-baked Boost libraries. What you want to do is you want to install them in a location, and with Linux operating systems, you want to install them in a location where the Ruby runtime could actually access them. What I did for that is here in userlib. Well, I'll just show you. So in this location, userlib boost 158, you'll see these are all the actual Boost libraries that I build through the compilation process that I mentioned earlier. Right. So now in this particular location, when the Ruby interpreter runs, it's actually going to be able to it'll be able to dynamically load these libraries or load these libraries at runtime. As you can see, these are .so. That means these are shared object libraries. Right. So with that. All right. So now I've got Boost installed and ready to be consumed on my. All right. But I actually don't have an application, so let's build something. So for the purpose of the demo, we'll do two things. The first thing we're going to do is we're going to build a little a C++ library, or a library like a dynamically loadable library that will be consumed by a Ruby gem. So our goal here is to build a gem that then is able to invoke, as needed, the Boost library. And that's what we're going to demonstrate here today. All right. So the first thing I had to do was actually create a library that could be consumed by a Ruby gem, and that's what I've done here. And we'll go through the code and. When I'm starting to do damage on time and things like that, right? Cool, thank you. So what I've done here, this project is in my repos or my GitHub area, so you can certainly check it out. But I'll kind of go through it very, very quickly. So there's a make file here. How many actually know what a make file is? Oh, cool, awesome. I'm like dating myself here. All right. these guys are with it. All right. So here is. Can you guys read this? Is this readable? So let's see here. So here's what we're actually building in this case. This is kind of this is the main library that's actually going to get exposed. It's libbooster, and you can just kind of see very quickly how this gets built. There's really nothing fancy to this at all. I'm just building this as a shared object library. So what happens is when you make this is, and we'll just go ahead and make it. This shouldn't take too long. Yeah. for us the shared object library. Now, let's take a look at the code and see what this actually does. If I can actually type. Yeah. OK. So just for the purpose of the demonstration, and create something relatively simple that demonstrates the capability here. So this is the actual So this is a little C library that actually does a couple things. The first function that it exposes is hello, just a little hello world function, right? That uses some of the Boost libraries as well as like standard string. Here you can see that this is using Boost regex, right? So here we're actually invoking the Boost libraries, right? But here it gets a little bit more interesting, right? So now here I'm creating a function that's going to calculate a binomial coefficient by using the Boost math binomial coefficient library, or just function that's exposed by Boost, right? So now it's getting a little more interesting, right? Or I don't know if you're interested in that sort of thing, right? And then the last one is just Boost, what I'm calling Boost for the purpose of demonstration. My library actually invoke the Boost, in this case, the Boost math factorial function. Now, Ruby does have a factorial function, but to my knowledge, there is no native binomial coefficient calculation function in Ruby, so that's an example of something that Ruby standard libraries today can't do, right? So that's the end of it. So here my library that I want to be able to consume in a gem, it does just a couple of very simple things, actually 3 fair, right? And that's what we just compiled, right? So that's the now let's go to the actual gem. So now we're going to go to a gem that I created that's actually going to consume this library. And this is where it gets even more interesting, hopefully. By the way, any questions so far before I jump into this gem? Yes, sir.
When you say consume, you mean it's just going to call the library and take advantage of it?
Exactly. Yeah, exactly. So is going to actually invoke the Boost library using this little wrapper, the little wrapper that I had built. So the wrapper basically exposes Boost as in the form of a C function, right? Expose C++ objects to Ruby in other words, extending Ruby to use C++ objects is a lot more complicated. In fact, it's just downright painful. Yeah. So. Yeah. In fact, Boost is all open source, so you can actually just go and take a look at how those functions work. But the functions that I have here, yeah. So that, as you can see, this is namespaced. Both of these are namespaced in Boost. So those are actual native Boost calls that are actually that's where my wrapper is now invoking the Boost functions, or the actual Boost libraries. Right? Actually, up there too. In this case, my first function actually does a algorithm to upper copy. Yeah.
So I'm not familiar with how Ruby works, but will this C code run in the Ruby interpreter, or will it run in the interpreter?
This will actually run. This will actually run in the interpreter. So this is actually as a shared object library. Mm-hmm. So this is actually going to be linked into the Ruby runtime. Cool. Any other questions about that? All right. So now we'll get into something that looks a little bit more familiar. So one last thing, if you remember back here, so we created, we ran make here, which invoked the make file, and the make file did compile the code and produced. It produced. Where's my mouse? There it is. It produced this thing, right? So we built this library, right? This is the actual binary code that's going to be invoked by the gem and the Ruby runtime, all right? There. We have a gem, right? So I've created a gem called Booster. Or mechanics of creating a gem right now. It's a little bit outside the scope of this talk, but Maybe that would make a good talk at some point.
Always open to you coming back.
So we have a gem. So if you've created gems before or worked with gems before, this should look relatively familiar. And I won't go through all of the artifacts that make up a gem, but we'll do kind of some of the big pieces here. So the first thing to look at here is what's called the gem spec. All right. So here's where we're really defining the gem, right? When you write your Ruby gems, you'll have a gem spec. You'll have something that looks pretty similar to this, right? So I won't go through all of these line by line. This gem is definitely not ready to be released yet in rubygems.org or anything like that. It still has a fair amount of work to do. On the right path, and it definitely works, and we'll do a little demo of it here in just a minute. The interesting thing to look at are here, the spec files or the specification files, right? So here I'm telling when you build your Ruby gem, you have to this section right here will tell the gem what files to include, right? What payload to include in the gem building process. So that's kind of important. So that's why I wanted to point that out. And then let's see. Let's see here. Oh, this is also very important. So these will probably look familiar. I have bundled an RSpec and make sure you write spec test. Of course, I haven't done that yet, but we will. But the last line here, this dependency is interesting. And in fact, this will come up in the next, I think in the next talk as well. This dependency called FFI. FFI is a very interesting gem that's written by some other interesting person. And what FFI does, it's a gem that allows people like me and you to be able to write native extensions in a certain way, or specifically C and C++ in a certain way. It defines its own DSL, or domain-specific language, for being able to create what it calls a native extension. But that DSL, it's all C code, right? It's almost all straight up C code, and we'll see an example further into the code. It's a really cool gem, and I have a link to it from the README of this project out in GitHub. So that's really the kind of little piece of magic here that's going to make this work. All right, and I'll show you how this works here. And that's pretty much it. So spec file. Again, these are all the files that we're going to include in the actual gem. And you'll notice here, this should look familiar, right? Because we built this in the last step, right? This is the actual compiled binary in the previous step. And all I did was I copied it into the lib location here under this gem, right? So let's explore this. What's in this folder just a little bit more. So we saw stuff that was in the lib folder, right? So let's take, in fact, so there it is, right? So there's the shared object library that we created from the previous project, right? So let's explore this just a little bit. So if you look in the lib folder, you'll notice that there was this thing, booster.rb, right? So this is incredibly simple, right? This is just a simple module, right, that we're exposing to the gem, right? That'll get mixed into the gem. And you'll notice the CPP boost, and you'll notice that it's, we're telling it to require. So you have, as part of creating a gem, you have to specify a version. You have to have a version file. Don't really care about that right now. But what's interesting here is that CPP boost, and we'll take a look at that and what that does. So all this is just a very, very straightforward module. Yeah. So let's take a look at that CPP boost. That's where all the action's happening. Curious, how many people here use VI or Vim for your editor?
I can't even say I do it often. Only when I'm doing something horrible on a server. Yeah. When I'm working on H+. Otherwise, I avoid it.
See, now I'm really aging myself here, right? Totally dating myself here.
Trying to work with somebody doing basis on only using Emacs.
Oh, there you go. See, now that I can appreciate.
Use anything other than Emacs.
Punch cards, those.
I don't go back that far, but anyway. All right, so this is some of the real magic with FS, right? So what we're doing here, we're creating a Ruby class called CPP Boost, and we're extending the FFI library, and there are a couple of directives here that we'll talk about. First is this line is very, very trying to do this while you're looking backwards is interesting. So this line actually tells the class where you have to in order to use FFI properly, you have to give it the actual full path. It has to be able to resolve the full path of the actual shared object library. It's a little clunky, but that's actually considered a standard way of doing it. The next three lines are this is the interesting part, right? So this is how we tell using this attach function. This is an FFI routine, right, or an FFI directive. And what we're doing here is we're now mapping the functions that we exposed in the C wrapper that we compiled in the booster lib project. We're now mapping those into Ruby, exposing them, right? So this is where they actually get created.
Does that have any concept of public, private, protected?
Well, keep in mind this is just a class, right? What we're doing here is just you know, and what we're wrapping is actually just a set of C functions. So they're in terms of the booster lib that we wrapped. There were no classes. It's all just everything's just functions that you expose. Something that's actually a good question. I mean, that's something that could be explored. It's probably possible to make these private if you wanted. So let's look at these real quickly. So the first one is the booster hello. You saw that at the top of that was the first function that we had, and all that does is take the input string and it converts it to an uppercase string, right? The next one calculates factorial, actually invoking the boost libraries in this case, and then the last one calculates a binomial coefficient, again, actually invoking the boost libraries, right? So let's take a look at the code, and then and how am I doing on time? Okay, great. Well, we're almost done here. We'll go through this code, and then we'll do a little demo, and we'll do questions. So the code here is simple. You know, I'm defining a couple of actually three methods, right? So here's the actual methods themselves. So I've got hello, I've got boost factorial, and then boost binomial coefficient, right? And you can see what I'm doing here. So when these methods get invoked, it's the FFI library that's actually going to map those back to my booster lib functions that I exposed. Sorry. Yeah, it's some just whatever mapping it does underneath the cover. And again, it's all open source, so you can actually go take a look at the code. I have something very similar to this for the problem that I had mentioned at the start of the talk that I had to solve. I've got something very similar to this running in a production environment right now, so I know it actually works. But being a cautious fellow that I am, I kept it as simple as I possibly could. And that's it. That's the end. So again, you can see that there's not a whole lot of code here, right? The hello function, the factorial, and then the boost binomial coefficient. So let's see this in action. Let's actually run and see how it works. So an invaluable tool when you're writing a gem is the gem console, which gives. Oh, by the way, you know what? Let me talk for just a moment about that I'm running here. So this environment for the gem, I'm actually using RVM to manage gem sets and manage Rails versions and things like that. So I've got my own booster. If you look at the environment just a little bit, I've got a .ruby gemset file and a .ruby version file, which helps manage that, and it makes things super simple. I know there are other alternatives to RVM, but again, being the old school kind of guy that I am, I like RVM. So we can have philosophical talks about that later. Okay, so we looked at the code. So let's go back into the gem console. This is similar to tools like PRY or just Rails console, things like that. So if you use those types of tools, this is very, very simple. So I should have this in. So now what I'm going to do, if I can find doing a bunch of tests with this. There we go. So the first thing I need to do is instantiate that CPP boost object. Remember in my module, or in my library, I had this class that I created called CPP boost, right? So the first thing I'm going to do is instantiate that object, right? Great. So now I've got an object of CPP boost called O, right? So now I can actually invoke methods against it, right? And by the way, a way to test as you write them, because as opposed to writing a full-blown Rails app and then find out later that your gem actually doesn't work, right? So love the gem console. So now, if you can see all the different object. This should look fairly familiar, right, or somewhat familiar. These are all the different kinds of object. And let's see if we can find up here. Here's my hello method, right, that we saw in my class, right. Here's my methods that we exposed, right. So they're all there, right? So that's a good start so far, right? So let's try hello. Let's see what happens here. Actually, I don't remember if this works or not. Oh, I don't remember the signature of the actual method itself. Well. Let's go back and look at the actual classes. Oh, it's actually hello. Huh. Oh, you know what? I don't think it's. I changed the just prior to the demo, and this is mapping the actual or matching the actual signature that I had in the booster lib. Let's do the other ones. I'm pretty sure. So let's do factorial. So the console, let's create our object again. We have that, and let's say, okay, so let's just compute the boost factorial of 3, right? And we all know what the answer to that should be. It should be 6, and there it is. Now, that's not terribly exciting, except when you consider the fact that in order to calculate that factorial, it actually didn't use the Ruby factorial functions. It actually used the boost libraries to invoke those functions, right? And then lastly, we'll do an example with the binomial coefficient, let's say of 10, 2. And we have the calculation. That function is actually in the standard Ruby library. So in order to make that calculation, it actually has the boost libraries. So as you explore the boost libraries, you'll see that it's actually really rich. There's actually a whole, there's a lot to it. There's a lot of scientific functions and just very, very powerful math library. And so you can see with this demonstration, it's relatively easy to expose those functions into a Ruby gem. Opposed to the alternative, which would be either writing your own, right, which could take a lot of time, or depending on somebody else, some third party, either gem or somebody else's, Ruby gem that, let's say, implements binomial coefficient calculation or something like that, right? Which may or may not. It probably won't have a bunch of other stuff that you might actually need. So, boost library, we made Ruby just a little smarter in terms of its math capabilities, but there's a whole lot more that you could do with this by leveraging the boost libraries in a Ruby gem. And that's the end of the actual talk and presentation. So if anybody has any questions.
So Boost is actually a great example for this because it is so complex. But is there anything to automate the mapping process? Because if you actually wanted, say, a Ruby wrapper for all of Boost, you'd be typing for a very long time.
Well, you know, I thought about that, and I looked out there for one. I found some projects that that try to dynamically like do introspection and you know figure things out, but I didn't get very far with that. Seemed a little too complex, and also it seemed really imprecise. The libraries that I found to do that seemed really. I think it might actually be a cool open source project to start. It was
even something like I mean, as much as I hate Gradle, a Gradle script could inspect the SO and generate all of the assignment lines on the fly.
That's actually a great idea. That would actually be a very cool experiment. But there's also something to be said for handcrafted code, right? I mean, and in this case, you know, everything that you find in the Boost library is going to be really suitable to expose in a gem. I think it might be a very interesting open source project to kind of create a curated gem consumer library and exposes the more interesting and relevant functions in, you know.
The nice thing is it's so modular, you could pick and choose.
Even
in your script, you could come up with a way of saying, you know, I only want you to wrap this section of Boost.
Yeah, exactly. Yeah, that'd be a great experiment to try. I would love that. But the purpose of this demo was just to show, hey, one, it's possible, and it has some really interesting benefits if you know, if anybody else that was doing this. So I thought, well, maybe either it's just a really dumb idea, no one's thought of doing it yet. So, any other questions?
Could you humor me and do o.ancestors, please?
Sure. Did I lose my object? Can I get ancestors in here? Huh. It should be in the theoretically it should be in the object chain. I'm sure. Did I lose my object? Did it get collected or something? Do you see it? There's o.class. Oh, wait, am I? Yeah, CPP Boost is the class. Yep. But feel free to pull this from the repo and play with it and give me feedback on it, because
Ancestors, if I remember, belongs to object, but it should print out all the inheritance tree for everything that you have access to from. That's interesting. Because I was wondering if there was going to be some sort of weird .so object.
I wouldn't expect the object that I'm invoking here doesn't. It doesn't actually know about the .so file, right? That's mapped by the FFI gem.
Okay.
So the CPP Boost object isn't even aware that there's this shared object library underneath. As far as it's concerned, it's just invoking these Ruby methods that were laid out in the CPP.
Thank you.
What's the general performance? I mean, I would expect at a certain point that this is faster, but obviously calling off one-off methods aren't going to be faster. But.
Right. You know, so far I haven't had any in the production environment that. So far, we haven't had any noticeable problems. We actually just launched an app that leverages some of this or this technique, probably about 4 weeks ago, and so far so good. You know, but I don't want to say that too often and anger the gods of software. And you know.
Well, I mean, like it's probably more of a question against FFI, but
yeah.
What's the overall performance like in Java, for instance? If you use the JNI, the performance difference is negligible. It's almost like calling it directly.
Funny you should ask that question, because I think the next speaker is going to talk a little bit about that. No? Yes? Maybe? Yeah.
Of like
Not,
calling native? I guess the real question is, what's the overhead of calling native? Is it substantial overhead in instantiating that class, so doing the creating your O object? Or is that? Okay.
Sweet.
Like I'm watching AJ's face.
And I think that's a question because it's being run in the JVM instead, or in the VM instead of having to call
Right. There you go.
Now, to be honest, I have not done a full. I probably should have. I haven't done a full like Linux stack trace to see, exactly, all the full details of it, and I probably should.
Cross your fingers and let it go.
Yeah, it worked on famous words in computing. It worked on my machine, so. So if there are no more questions, I have one question for all of you. How many of you guys how many of you people use Evernote? Yeah.
I have it, I just never use it.
How good is it?
Good job.
Take it.
I don't.
Interesting.
I have a mix with it.
Okay.
Until it ate some a few years ago.
Good to know.
I
Good to know.
moved off of it, but I've heard it's better now.
Last question. When you do projects, whether they're school projects or research projects in your professional environment, what do you use to like manage all of your stuff? Links, images, videos, just all. How do you manage all of your stuff? Anybody use any kind of bookmarks? is so far the win that I keep every time I ask people. That's what I hear.
Yeah.
Dropbox and bookmarks. Yeah. Okay.
Yeah.
Okay.
Or I'll just throw
We
like
use
a
a
quick.
media wiki because our company won't spring for anything better.
Gotcha. Gotcha.
Got Confluence. in it.
Sorry.
Yeah,
For
that's
links, images, and videos. Everything that's it.
Have you ever used a product called Pocket or Get Pocket?
Never used it.
But no one really. Are they local?
I think they're local.
Oh wow.
I don't know. I've heard of them.
Well, they claim to have 16 million users, but I find that claim a little dubious. But anyway.
I've heard of them, or they've done something up here, because I feel like I've seen something.
Really?
Does that ring a bell to you then?
Okay.
Maybe I'm thinking something weird.
Anyway, because I'm like all of you, I've got a little side project going. So that was my. No. No. No, my background, the only that I've worked for I work for Malwarebytes, which hopefully some of you recognize as kind of an important company. I've worked for Microsoft up in Seattle, worked on the Exchange. I was part of the Exchange team, so which runs like email all over the world. If you've never heard of Exchange, let's see, before that's interesting. Not really anybody. Worked for a bunch of security companies, so I've been in security, computer, like anti-hacker, anti-malware companies for like the last 10 years.
I have a general question about
Sure.
software development.
Let's see which
It'll probably sound a little bit naive, but like, what is the main objective in writing these further abstraction levels from the more close to the metal languages? So you're referencing C and C++, C being the oldest,
Yeah.
most close to the metal language that we've been discussing. We're working with Ruby here tonight.
Right.
Action on top of these other languages. We work with JavaScript on a regular basis.
Yeah.
PHP, Python, you name it. What's the main motivation in writing these further abstractions away from the raw languages, other than it's more to apprehend the obscure nature of these primary languages?
I think if you ask 10 different programmers, you'll probably get 10 different answers for that question. I'll give you hopefully a short version of my answer. Then I'd be curious what other people have to say about that, because that's a very good question. For me, it's about picking the right tool for the job and the right language for the job, right? It depends on it just depends, which is kind of a Weasley answer, but it really is the truth, right? You can write an awful. I'm not one of these. I don't have religion about things like, let's say, even for example, object-oriented programming. I think it's possible to write a lot of very good and ship a lot of very good commercial products with like just straight up functional programming and C. I'll give you a great example. I used to live in Dallas, Texas, which is the home of it's a local legendary software company called id Software. They were the original creators of Doom and Quake and all those video games from way back in. All that stuff, they've open sourced a lot of these code bases now. If you look at all this stuff, we're talking multi-million-dollar legendary products, right? It's all written in C, right? There's no C++ even. It's all just straight functions in C. They're not, but it's all at the end of the day, it's just C code, right? So there's a lot of people that are very pure about, oh, it must be C++, and I don't really buy that. as far as the higher abstractions go, and you could look at C++ as an abstraction of C, theoretically. You know, with languages like Ruby, and the reason, like for example, with a lot of the projects at Malwarebytes that we chose it, and we use a lot of different languages, right? For most of our backend systems, we use a lot of Ruby and a lot of Rails, right? The reason we chose that is for a couple of different reasons. Number one, time to market, right? It allows us, by working in higher levels of abstraction, it allows us to use the previously built building blocks of these frameworks instead of having to write our own. And we know that they're good, and they're certainly good enough because millions of other developers use them and have fixed countless bugs in them and things like that. Same thing is true with, I've done a lot of Java programming as well. Same thing is true with the Java runtime, right? You can write, there's so many building blocks that you can pick up and just use, right? And now, if you need, you know, truly operating system, you know, real-time performance, things like that, a lot of optimizations you can make. You can do interesting things like this, perhaps. You know, I remember I was in an airport one time, and some guy next to me was telling me what he did C++ programming for some financial, where they were trying to do like these really fast trades. I forget what the high frequency trading, I think, is what they call them. Which I just thought, you know, you D-bag, what a terrible way to make a living. But anyway, that's just me. Wait, did that just go live over there? Anyway, whatever. You know, his argument was so, I thought, just generally lame, right? But he just thought it was kind of impressive, and thought were his technical ideas behind that. I thought they didn't have any really technical foundation from what he was trying to do. But that's just me. So for me, it's all about getting your app to market faster, and being able to get the value out of it faster, as opposed to being able to of native code. Right. Yeah. I'd be curious if anybody else has an answer. Did you make a comment to that?
I like writing Ruby. I don't necessarily like writing the other languages. And there is a certain cost making write a language that takes more time to learn, is more prone to.
Yeah.
And like market also cost to market is a factor there.
That's true. It's very, very true.
A big one in interpreted language too is, you know, as the development world gets larger and larger and larger, you know, as much as we like to think that we're getting better and better and better, we're not all, you know, Linus Torvalds and stuff like that. So the ability of your average programmer to be able to properly track references and stuff like that is pretty minimal, and the interpreted languages help deal with that without causing catastrophic failures.
You know, and I'll just tell you about the real world examples from how we use things. You know, we use Ruby and Rails a lot. Some of the, we have, on a, we'll have something like 20 million endpoints contact our back and phoning home saying, hey, do you have any updates for our new malware detect, things like that, plus giving us, you know, operating system, this basic information that we need. We have to be able to respond to those requests literally millions of times, and that's a lot. So the back-end system is in Ruby, believe it or not. A lot of it, we've become really keen on a relatively new language and platform called Golang, or Go. And so we're very interested. We've done a few projects with that now and really liked the results. And so we don't do much Java right now, but that might change as we do a lot more big data stuff. Sorry if I'm like way over time. Let me.
We can continue the combo after. Obviously, you were able to pick everybody's brain after.
Sure thing. Let me get this off the screen. It's always fun doing that like when everyone's watching. Right?
I know, right?
Okay. So
while we're switching it around really quickly, raise your hand if you did not get a ticket, so I can roll out the list. Who else did not get one?
what's that? Oh, thank you.
You're welcome.
There. And let me unplug this, or unhook myself. There you
You
go.
are good. And for those who don't know, we do take everybody to a round of beer over at World of Beer right after to allow. I suggest a lot of you guys do that so we can get to know you better. I've got a mic. I got a mic. If I'm not giving you a heart attack yet, I might be now.
I'm good. Message for YouTube.
Uh-oh, which one now?
I've made a written version if they want to read it.
Cool. Nice.
Listen online.
Yeah? Did you put it in the meetup page or?
I will afterwards.
Okay,
I
cool.
didn't want them reading it, before. Hello, YouTube. Just so you know, there's a written version of the presentation I'm about to give, which you are welcome to look at. If you're interested, you should head over to aj-foster.com and take a look at the first link towards the bottom. It'll be titled, I actually don't remember, Using Other Languages. And if you can't hear me on YouTube, just raise your hand and I'll definitely see it. I think that's yours. Thank you.
Thank you so much, Matthew.
I couldn't believe what he said in Friday for his thing. I liked it.
Good. Need to say anything beforehand?
All right, everyone, you ready? Time for talk number 2.
So I'd like to thank you all for coming out to this lecture of MAP 5712, Bayesian analysis, and other Markov processes. Not going to dive too deep into the math, just going to do a little preliminary stuff, and you can pick up a syllabus on your way out. It actually worked out nicely. We both have math degrees, so I think you were expecting Ruby, but you're actually going to get math. Sorry. Just how the way life works sometimes. So what we're actually going to talk about is using other languages in Ruby. Presumably, you're all here because you like writing Ruby. If you're not, a bit confused. But we can talk. Okay. AJ, I'm a graduate student in mathematics at UCF, the Department of Physics, doing things that have absolutely nothing to do with Ruby. But Ruby is a language that I really enjoy writing. So anytime I have free time and have a chance, I'll do a project in Ruby. And that's why I'm here. We like writing in Ruby. That's presumably, but sometimes we need things a little bit faster. I don't know if you've heard, sometimes Ruby can be a bit slow. We'll see that again later. And sometimes we have to use other languages for whatever reason, whether it's someone's like or we want to use a library that someone else has written. This can be frustrating, right? Because we like Ruby, and we don't want to use these other languages, but sometimes we have to. But never fear, because we can still use those languages, as you just saw, with methods. I'm going to talk mostly about C and C++, but I'll also try to touch on Python and the R language, since those are two languages that I've had to work with and I've wanted to use Ruby with in various circumstances. As far as C is concerned, you could always make a shell call from your Ruby and run a C object file. You can just compile the C separately, and Ruby can run it as if you were running the C from the terminal yourself. That's always. You can do something like FFI, which is what you. And I want to show you one more, which is called Ruby Inline, which for very specific use cases is pretty interesting. Let's see a little bit about how those work. What we're going to be doing throughout here is using or demonstrating using the naive implementation of Fibonacci. It's a lot like this. And I want to make it a point to type this in front of you just because when I was learning, that seemed to hurt. Not hurt, help. Goodness. Yes, I want to hurt your knowledge about all of this. That seemed to help when I was trying to follow along with code at a meetup or otherwise. So an astute and energetic will notice that this code is going to call itself many, many times. If I give it the number 42, it's going to call, for example, Fibonacci of 2 a large number of times. There's a huge number of function calls. It's going to explode exponentially. It's not a good program, trust me, but it's going to be OK. And around the CS world, it's, I'm sorry? Oh, yeah, thanks. I appreciate you. That would have been interesting. Why is it not stopping? Yeah, so if you see something, please do shout at me. Maybe not shout, just. We're going to need that later. OK, so here's just the most basic C code for running this naive implementation. And if just have it print out a result, give it a number, have it print out a result. We could do this. Dual arguments. And we'll have it just print out the number, run fib on whatever we give it. So this is pretty basic stuff. I hope you weren't coming here to learn advanced CS with C, because I can't. So we'll just call this fibc. So if we want to compile this and run it, it would look a lot like this in our Ruby. We'll just do a shell call with the back. We'll have probably compile it as fib.o, and we'll give it a number to deal with. Very simple. Ruby's just executing a shell call. It's going to the system saying, there's this object file called fib.o. We don't care that it's C, but run it, give it this number, and then we're going to print the result that it hands back to us. Pretty simple stuff. So that's just executing straight C. C, no language bindings, anything like that. And if you need to do something quickly, and hopefully no one you to manage this code, you can just get this out of the way. The second method uses FFI. I'm not going to go through the code because you saw it earlier. You are defining a class. I called mine fibtest, and you're telling FFI that we want to use a shared object file, which is the compiled version, and we're attaching the function fib, just like he did with the various booster functions that he wrote. Third, I want to show you Ruby inline, because it gets to be pretty cool. Ruby inline can be installed with just gem install Ruby inline. The R and the I are capitalized. It matters. And use this in Ruby. It looks kind of freaky, I will warn you. So, similarly, we'll define a class. And the Ruby inline DSL has this whole inline method. And we'll use or define our variable to be called builder. Now, what Ruby inline is going to do, interesting, it's actually going to take the C code that we give it as a string and compile it while making some changes to the way the code is formatted. So the Ruby inline is actually going to do a little bit of translation to the C code that we hand to it, and change the arguments that it uses, and change the type of the arguments that it takes. Because of that, what I'm going to do first here is build a prefix. When you have this prefix, it's going to use the raw C that I give it. In a moment, after I've done this, I'm going to say builder.c and hand it a different function, and it's going to actually translate that C into something that Ruby can. It'll be much more clear in a moment. Our little fib function, so cute. And I'm literally just copying and as a string. Let's see going on. And I'll call it fib inner. And now, in a moment, we'll have another builder. This one fib. So what I'm doing here is I'm avoiding a bit of a mess. Because this Fibonacci function is recursive, it needs to call itself. When Ruby inline goes and it translates the Fibonacci function that we're giving it, it's going to change the arguments that that function takes and the types of those arguments. So if that function wants to call itself, it's going to have to match what the changes that Ruby inline is going to make. I don't want to have to worry about it. It gets confusing and messy. So what we're doing here is I'm exposing a function called fib, and it's going to call this other function fib inner. That fib inner is built using the prefix method. So it's raw C. It's not translated by Ruby inline, so we won't run into any of those problems. Whereas this fib function, in our case, is going to be translated, but it's OK. It doesn't need to call itself.
What's going to happen to the recursive calls?
Once it escapes from fib into fib inner, that untranslated function will keep calling itself, just as if it were running in C without any translation.
So it doesn't invoke any Ruby layer?
That's right. When you build with prefix, it doesn't do anything to it, and you can't access fib inner if you wanted to, unless you do some tricky stuff, which is beyond this. So let's end some things. If we want to run this, we will have to create an object. Nothing new there, except something new. And if we want to print it out, we just have to do that object that we just created, and the method that you use matches the name of the method that you built with builder.c. Pretty simple. So you have to make sure that you're not conflicting with anything, namespace the class appropriately. So this is how it would work. Oh, that's atrocious. OK, so we have this inline object, which is of class fibtest. In that class fibtest, we built using these C functions just as strings dropped in there. And we're calling a method that matches the name of the method we put in there with builder.c. I'm going to let you trust me that it works, because it does, just in the interest of time. Because I do want to talk a little bit about how these methods compare in terms of runtime. Let's compare. Straight C, that's just Ruby calling the C function as normal, as you would via the terminal. Nothing special there. I gave it the number 43. A lot of function calls being made. You have to give it somewhat for C to actually take a non-trivial amount of time, because C is fast. Ruby plus just takes just a little bit more. Ruby layer acting on top of the C, you get 0.1 seconds of extra runtime as a result of that, which I think is easier writing Ruby code instead of C code. But it's something to keep in mind. The interesting thing to me is the Ruby actually performs better than either FFI or calling the C code on its own. Now, Ruby inline, as my understanding, it takes that code, runs straight in the Ruby interpreter, much like FFI does. If you want to compare Ruby inline to the straight C, the reason for the performance increase is because you don't have to ask the kernel to give you some memory, allocate memory for the stack and heap, give you a process for the C every time you want to run it. And that sort of OS overhead is what's missing from that time. Just as a little comparison, let's add in Ruby. Write a Fibonacci function in Ruby. It's a little bit slower, it turns out. Just a little bit. Yeah, it's kind of embarrassing.
So do you like Ruby just because it gives you like coffee breaks?
Yeah, could be.
Nothing wrong with coffee breaks.
Yeah. So that's C. I do want to talk very briefly about Python. I've had at least one occasion where I'd want to run Python inside of Ruby. And there's a gem for that. Surprise. It's called Ruby. Who knew? So literally gem install Ruby Python. Nothing's capitalized. Here's a little bit of how it would work. Another big surprise, you're requiring Ruby Python at the start of your code. Nope. So what it does is it actually embeds a running Python interpreter inside of your Ruby interpreter, which if you try to wrap your head around it is going to hurt after a while unless you do it at least 10 times. So in this case, we just start the Ruby Python, literally .start. And that starts up the Python interpreter. And here we can start doing interesting things. One package I work with a lot in Python is NumPy for a bunch of the numerical stuff that they do at the. So it would be nice sometimes to be able to work with NumPy's method inside of Ruby. And we can do it just like this. Any method that you can use from the NumPy module in Python, for the most part, you can now use on this NumPy in Ruby. It does the translation for you, which is kind of nice.
This is still an RB file, not a PY file?
Still an RB file. You can do this in herb if you want it. Herb. So if you actually, it'll return module NumPy. It looks just like a Ruby module. Unless you start digging into it, you won't notice the difference, which is cool, because I like Ruby more than Python, it turns out, as I'm speaking up. So if you want, you can even use objects that that module supplies. So for example, NumPy supplies an array object. And we can just call or create the exact same way we would in Python. And if you do that, it'll return a NumPy array, just like it would in Python, which is nice. Now, I warn you, to a certain extent, you're limited to the syntax of both languages. You kind of have to meet the least common denominator between the two. So for example, with NumPy, there's special syntax related to array splicing, and this. If you want every second element, you could do something like this. You can't do that in Ruby because it stares at that bracket : :2, and it has no idea what you're talking about. So you kind of have to work around that. And that can be annoying if you're a diehard Python developer wanting to use Python's features. But if that's the case, writing Python, not Ruby. So it goes hand in hand. Ruby python.stop just stops the Python and back in your good old Ruby land. It's nice. Now, I should warn you, I ran into a very interesting circumstance when I tried to use the array object after stopping the Python interpreter. Ruby, in general, doesn't deal with seg faults. at least it doesn't deal with them very well. This array object was at least partially allocated in the Python interpreter's memory space, which no longer exists. And if you attempt to access any array or any objects that rely on that interpreter space after it's closed, you're going to be in for a bad time, let me tell you. No clean exception catching for that. It just dies. One last thing for you, and that is the R language. Once again, surprise, there's a gem for it. I think you see a common theme. It's called R in Ruby, which I think is nice and descriptive. Literally, gem install R in Ruby. Literally require R in Ruby. And you can do much the same as with Ruby Python. You're just supplying the code that you want to run in R as a string. A lot like Ruby inline, except you get to do. So the interesting thing is in the output, if you're running this in interactive Ruby, show you the code that R is running in order to give you what you asked for. I don't know, I'm not all that familiar with R. I don't know why the output is so verbose, but it's kind of interesting to look at. It's kind of cool. So using string interpolation, you can pass back and forth. If you some sort of normal distribution, given a sample size, you can just do that. And it's going to return to you as both a lot of text output and as a true-false, whether it worked or not, what R would give you back, which is nice. That's most of what I have for you. Are there any questions?
When you ran the Python, when you started the Python interpreter inside of Ruby, is that running in a separate process address space? I mean, it's just, how is that like when a Python object gets instantiated? Where does the memory get allocated off the heap, or how does that work?
I couldn't tell you. I don't know the logistics of exactly how it works, but I do know it is interesting. Yeah.
That's kind of cool that you can do that. It's actually really cool that that would be make me a little nervous.
Yes.
Yeah.
I wouldn't necessarily recommend running it in production, but
Yeah.
for certain use cases, there have been times when I would have liked that, and I didn't know about it. Other questions?
What's the startup latency on that?
For actually running rubypython.start?
Yeah.
On my Mac, almost instantaneous. I didn't notice anything. So, and you only have to start it once, so
Right.
that's nice.
You pointed out bad things that can happen when an object, when you try to access an object, garbage collectors, monocle scope, things like that, when you're running the Python interpreter inside of Ruby. The same thing is actually true with Py. In fact, if you get Py gen page data, they'll give you cautions about that when, like, let's say if you pass a string as an argument into an Py mapping, and you ask like copy the data into a local variable, or else the Ruby garbage collector just types to garbage. You're trying to dereference something that's now valid. And that gets fun.
Oh yeah, always a fun time when you dereference something.
Check out my old version.
Ooh,
Oh,
ouch. Other questions, comments?
But I mean, something for me to go home and look into, but I imagine you already have. If you're running Ruby and Python like asynchronously, how do you get the data out of the Python environment and into your Ruby?
It's interesting. You just have to be careful and make sure that you aren't using any objects when you do so. If you declare a fully Ruby object, like whether it's a string, number, whatever, and it has no relation to Python, you're fine. once the Python interpreter closes and all the memory goes, it's a Ruby object, so you'll be good to go.
What about if you try and set, say, fields based on the results from the Python? Will it keep a reference to the Python, or will it try and copy, or is that something that I've never used Ruby, so I'm not sure how it works?
It's strange.
Okay.
It's the best.
So no guarantees that
Yeah.
it's going to be safe if you copy it into a pure Ruby object.
Right.
Okay.
But with anything, anytime you're dealing with just working together, it's just another layer to think about. And
it's typically one of the hard ones because you're marshaling data structures from one environment that may or may not even make sense in the other environments. And the question is, how does one runtime understand a data structure that it knows about? How do you tell an environment about that? With the primitive objects like, let's say integers, things like that, or characters, it's relatively straightforward. But and that's also one of the reasons I like because I had actually looked at Ruby inline and I didn't understand enough about how it worked, and I was under kind of a time crunch as well. That's why I looked at F5. But if you look at F5, it actually spends it's one of the reasons I liked it also, and I think it's also a very popular library, is that it actually does work for you to manage the marshaling of more complex data types, like let's say, for example, structures. Like so C structures, map marshaling those in and out of Ruby code. It actually does a pretty good job of that. It gives you like this VSL, this whole VSL that helps you, because that is actually probably of the whole thing. You marshal in and out data structures that aren't native to that platform or native to that environment, and then probably the other really tricky things are memory management, and then if you want to really hurt yourself, like running multiple threads, trying to spin up multiple threads from one environment.
Concurrency's hard enough on its own.
yes. And in reference to the earlier question, I think it was yours, as far as private, public, that sort of thing, I'd just brief. So it's possible, but you have to really we're on in terms of which language you're working in. As far as I know, the tools are there. It's just getting them to work together is always the easiest.
When they fire up a Ruby interpreter as a Python interpreter, and the Ruby interpreter inside of the Python interpreter, the Python interpreter talk back to the other Ruby.
Yeah. Cool. If there's nothing else, thank you for your time.
Here comes Doug. All right, everybody. Thank you for
Oops, sorry.
those amazing talks, guys. You guys are awesome. Thank you. It's probably one of the most in-depth talks that we have had, so we rarely go